can hear me. So today we are going to look at particularly a different topic from what we have studied so far. So far we have covered a lot of different areas, like starting from authentication. We mainly focus towards access control, and different access control models were discussed. And now we will be starting a different topic, that is SQL injection. So if we start from the beginning, where SQL injection was initiated, so it's back in the history where people started to look at different systems in specifically like in the past, when the operating systems like Unix gained popularity and were used in most of the systems, right? Command line interfaces became standard. So software started to use commands internal. So basically, the software systems at that time, when they were implemented, the developers executed some of the operating system commands through these command line interfaces. So system commands were used to interact with the operating system at that time. So this usage of operating system or the system commands, it was like used without proper validation of user inputs. So that is how the systems were built at that time. This is like in 1970s and 80s. So then thereafter, web solutions came into the usage. And so in both cases, when software systems started to use system commands internally, and when web systems also using these system commands in their back end, attackers or the malicious parties realize that there is a way that they can take advantage of these systems by passing operating system commands, by injecting those commands through user interfaces where these software systems and web applications fail to validate properly. So what happens is, in a user interface, the developers might be expecting something different, whereas malicious users enters malicious code or malicious commands through these user interfaces, where it will be executed in the backend as operating system commands. So that is where things started. So before we experience SQL injections, command injections were there. Because of this inappropriate or maybe improper validation of user inputs. And at that time there was no much attacks, so the developers were not so paying the attention to those attacks so much. So that happened. Then with the evolution or with the advancement of the technology, uh, for web systems, they started to use these databases, especially relational databases where SQL, structured query language queries, were passed to interact with the database in the backend. So the same thing happened with such applications where users or the attackers started to pass SQL commands or SQL queries through the improper implementation of the user interfaces. So through these user interfaces, attackers started to pass SQL commands through these user interfaces to the backend in the database, where it executed these malicious SQL commands and behave in an unintended manner. So that is what we call SQL injection. So everything was particularly similar with command injection, but the place where it actually affects is different. So that is the little bit of history. And then we have NoSQL injections, LDAP injections, all variety of injection type attacks. So let's look at what is command injection. It's a type of security vulnerability that allows an attacker to execute arbitrary commands on a host operating system via vulnerable application. So it summarizes what I have said so far. So when we have software systems with improper implementation of user interfaces and their input validation, so attackers, that they can pass arbitrary commands to the host operating system through this improper implementation of the user interfaces. This happens when an application passes unsafe user supplied data to a system shell or command interpreter without proper sanitization. So this is just an example, I mean a very simplistic example. Let's assume that there is an application to resolve a given domain name. So what its all purpose of resolving a given domain name. So if you give www.ucc.lk, it will give you the corresponding IP address, that kind of application, right? So that let's assume that the developer of this application has implemented this system or the application with PHP, and how he has implemented is like this whatever the user input, that user type will be received in the backend through the get variable, right? The get command, and it will be the user pass data, right? So whatever the value user pass will come to here. Then what the developer has done is the developer has executed a ns lookup command, right? So ns lookup command with the given or the past user uh, input, right? Assuming that user would enter a valid domain name. right? So if we enter www.ucsc.lk here, so it will execute ns lookup www.ucsc.lk, and it will have the result of that command. And what happens is this result will be pass-through command is about uh, printing the output of this uh, command ns lookup, and printing it in the front end, or maybe the client side interface, or the browser, right? So what the user would see is the result of this ns lookup command. So that is the intended behavior of this application, and how it has been implemented. So this pass-through command in PHP executes a command, and the output is passed back to the browser. So that is the whole purpose of it. So what if domain name? So what if a user passes this string here, right? So it is basically 127001 and some encoded text, right? So if we decode it, so it is basically, this is the text that the malicious user is passing, and perhaps the user has some information, internal information, that there is a secret file in this host machine in the root etc directory. So now the user is attempting to pass this entire text, which is encoded like here. So what happens when the user passes this text here, it will go back to this PHP script in the backend. So it will attempt to ns lookup the ns lookup the particular part, this IP address, and whatever the semicolon will separate these two commands. So ns lookup will be one command, and there is another command, cat. Cat is basically uh, extracting the file content and printing it in the whatever the output medium, right? So the same thing will be executed with this pass-through command. So it's like this pass-through command has received two commands to be executed. So uh, it doesn't avoid it, right? So it basically executes both commands, and there is a very high chance. So if this file exists in the directory, so this will be printed in the browser output. So it's basically seeing the content of this file. So that is a vulnerability in this system, right? So this is a very basic example of a command injection. So we pass a command to a user input where the developer or the party who has built this system has never expected. So again here, this is another application, and there is a PHP script, and what is the intended behavior of this script is it will receive uh, a name of an author, right, through the interface, or the web application interface. There might be a text field that you can type whoever the author's name. So that author's name will be passed to the backend, and the script will receive it here. So now the author variable is holding whatever the author's name. And then what it does is it it builds a path string. Path string is where this author's biography is stored in the directory. So now it concatenates this author's name with the uh, previously identified path string. And what it does is then it reads this file, right? Read this file where the author's biography is there. So it will be printed back into the browser. So it's like if you want to see a biography of, let's say, William Shakespeare, so we type Shakespeare in the user interface text field, so it will locate the particular text file in the disk where William Shakespeare's biography is stored. So it will extract this biography and then read it and print the biography in the browser. So user can see. So this is how the developer has implemented this code. So then what if instead of a author's name, a malicious user pass this particular string, right? So it's basically locating the etc password file, right? It's basically locating the etc password file, right? So it will be given as the author's name, so it will be concatenated here, right? Concatenated here. So there is double dot slash, it means going going a directory up and again going a directory up. So there you will be in the root directory, root etc password file. Now this password file content will be read and will be displayed in the browser output. So that is uh, the risk of this implementation. So if the user knows a particular file in the host machine, and the malicious user can locate it and read it to this application, any file. So if the permission allowed. So this etc password file will not have, I mean, the user will not be able to extract the password, but it will contain some sensitive information that should not be shared with any public user, right? So that is the risk. For prevention, so language specific filter function can be applied, which means PHP specific. So this script has been written in PHP programming language. So we can apply language specific filter function. Or another option that we can do is allow access only for specific directory or list of directories. So if we are allowing this application or PHP to run and access a particular directory, we may allow accessing this program to a particular directory or list of directories. So then it will not allow accessing directories such as etc. So that is a way to overcome this. Another example, right? So let's assume that there is a user interface where you can send emails, right? So sending emails. So what happens? There might be a text field in the user interface. You can specify what is the email address that you want to send a particular email, and then you can specify the subject, right? So then what happens is, so if you specify email address and subject, then you can send an email which is containing some particular information which is available in this mail body text. It's not like you can send whatever the email content or text you want, but when you specify the email address and the subject, so it will send you some particular detail which is stored as a file in the host machine, right? So it's like getting the details about something. So the system sends you, or sends system shares some details or the information with the given email address, right? And you specify the email, right? So you specify the subject, so it will send the email content with this given email address and the subject. So what if a malicious user specify attacker or maybe a malicious user's email address, and as the subject, the malicious user passes this text, right? So what happens? So this particular content text will come here, right? So the variable subject will be replaced with this text. So what happens is this application, so it's a system call, system command, and it is basically through this mail command you can send emails, and uh, so you have specified attacker's email and the subject, you give this text. So the subject will be foo, and then the attachment will be etc password file. So the semicolon separates these two commands, right? And after that, this ls command with this part will be executed, which is useless at this point, where this malicious user has taken etc password file and send it as a email to attacker's email address, right? So the basically attacker can extract, or attacker can receive emails with any file within this host machine which can be attached to this particular email system, right? So that is another command injection type of attack. So as a prevention mechanisms, prevention measures, we can filter special characters. So basically we can uh, filter user inputs when the user input is passed to system, right? So that was about command injection, and let's see what is SQL injection in that case. So SQL injection is something similar, right? So earlier we passed a command to the system. So in SQL injection, we passes, or the malicious user passes a piece of SQL command or SQL script through applications input fields where the developers have failed to validate these user inputs. So with the poor sanitization, these SQL code segments will be passed to the database and can be executed by the database engine, and the results will be received back in the front end. So this alters the developer intended behavior, which means the developer may have developed the application, built the application with a different intention, but the malicious party is using this application to leak information or maybe any other malicious activity. And if we look at SQL injections are still a critical type of attack types or maybe a risk, right? So this is OW ASP top top 10 web application security risks, and it was released last time. It was released in 2021. I'm not sure that whether they have released 2025 list yet, right? So, somehow they have to release a list in 2025 because they usually release a list in 5 years. So you see that injection attacks are still a critical type of risks, right? So in 2017, it was the top one or the first in this list, but in 2021, it came back or dropped to third place. So injection attack slides down to the third position. 94% of the applications were tested for some form of injection, and mapped into the category have the second most occurrence in applications. So if you look at SQL, structured query language, it's a domain-specific language we use to interact with the relational databases specifically. So we can do a lot of things, do data manipulation with this SQL queries. Basically, we can create data, or basically inserting data, and we can retrieve data from the database. We can update data, and we can delete data. So that's the type of things that we can do with these SQL commands. So it's a domain-specific language where we usually use when we want to store data in a database. So if we look at how typical web application works, right? So you will see that there will be 3 layers mainly, right? So right now there can be much more complex than this. For simplicity, we identify 3 main tiers. Like you will see that presentation tier where the user interfaces are given to the users. And if you look at any web application, right, so you will see that there are user interfaces where users can interact with the system. Users might be passing data to the system, and user might extracting data from the system, right? So doing certain transactions, things like that. So there will be user interfaces where we refer it as presentation tier, and it's mainly the interface between the system and the user. So that's why we call it user interfaces. So whatever the user data or whatever the process that you want to execute, that there will be a user interface to interact. So through the user interface, you pass the data, and the role of presentation tier user interface is basically accept user inputs and pass it to where the particular data will be processed actually. So let's say we are going to register with the system. So we basically provide our basic inputs, basic information like name, address, and all other details, and we press the submit button. So this data will pass to another component or maybe some other program uh, which will accept this data and start processing it and doing certain validations and building some sort of internal representation before it will be stored in the database. So that is basically logic tier. So you pass the data to second layer where it will be processed in a particular way, program specific way, or maybe the application specific way. So the program logic will determine how the data will be processed, right? So the presentation tier is basically to interact with the user. So accepting user inputs and perhaps sending the output of the system back to the user. So that is the mainly the responsibility of presentation tier. So it will not meant to uh, process data. So processing is happening here in the logical tier. So it will process data in a application specific way, and the logic tier will ensure that whenever it wants to save the processed data in the database, so it will pass the data to the database, and if it requires extracting data from the database, again it will interact with the database and take the necessary data out of it and process it in a particular way and pass it back to the presentation tier, so it will be visualized or displayed to the users. So that is how a typical web application works. But right now, if you think about complicated or maybe complex uh, modern web applications, there might be more than 3 tiers. So you might be using, or the developers might be using different programming languages to build these different tiers, like presentation tier. It might be using different programming languages for logical processing this data. There might be different programming language. Interact with the database, you will have again SQL kind of uh, programming or SQL kind of very specific language. So this is where you need SQL, right? So interact with the database. So as an example, if you type URL, web resource you want to extract in the browser address bar, so that resource will be located and passed back to the browser. So if data processing is required, so basically you might be entering some data here, right? So when you press the button OK, so it will be passed to web server in the particular hosting system, right? So yeah, you will see that logical layer is there, and your data will be processed, and in a way that if it requires to interact with the database, it will interact with the database through SQL commands, and it will retrieve data and process it and sending the response back to the user in a presentation tier. So as I said earlier, nowadays this architecture or the typical web application architecture is not particularly three-tier architecture. It is n-tier architecture, which means there can be multiple layers in between the presentation tier and the database or the backend. So application logic builds dynamic SQL commands. So typically these web applications, based on user inputs, it will internally build dynamic SQL commands, right? Based on the user inputs, right? So let's say you are looking or you are searching a hotel in a web application where you can search hotels based on a particular criteria. So you specify your requirements, like where you are going to search or where you are going to find this or the place of the hotel, right? Let's say you are searching a hotel in Colombo. So this Colombo is a user specified input, right? So based on this user input, you are going to search the database in the data, right? So let's say you want to search hotels in Colombo. So you will enter Colombo somewhere in this user, right? Colombo will be passed to the web server and it will do the necessary processing. And so the hotel data is stored in storage tier in the database, right? So if we are going to extract hotels in Colombo, so we have to build a SQL command which filters Colombo hotels. So based on the user input, we are going to build a SQL command here in this business logic tier. So it will dynamically build a SQL command which attempts to filter out Colombo hotels, right? So another user might be interested in hotels in, let's say, Kandy, right? So that is a difference. So the same SQL command you use to filter out Colombo now cannot be used because that SQL is about Colombo hotels. So if you want to filter out Kandy hotels, again, that SQL command should have Kandy as the parameter and it should be dynamically built here, right? So that's why we call that dynamic SQL statements are built with the user inputs. And also you might specify particular price range, right? So the price range that you are looking at, like 20,000 to 50,000, and the star category, right? And hotel types, and so much of different criteria might be enforced through your query, but it has to be built dynamically in the system so the database can be understood, right? So that is how it happens. So the software system in the middle of this application or the business logic dynamically build these queries. So after building this query, that query will be passed to the database and interact with the database as we want. It's not about extracting or retrieving data. It's sometimes when you want to store data, right? So let's say you are going to register with the system. So you are basically passing name, email address, and all the telephone number and all this data. So that SQL query, which is used to store your details in the database, should contain your own email address, your name, your telephone number. So it is different from some other users' SQL that was used to store their details. So this SQL is dynamically built, and after building this SQL, that will be executed at the database. So application logic builds this dynamic SQL commands based on user inputs, and applications are authorized to execute such SQL steps. So applications given the authority or authorization is granted to execute these SQL commands on databases. So dynamic SQL statements may include direct or indirect user inputs, which is vulnerable. So these dynamic SQL statements that the application build might contain user-given inputs too. As an example, the hotels in Candy, hotels in Colombo. So that Colombo Candy is the user input. So user has passed this input, where this input will be a part of the SQL command that the system built. So that is the vulnerability, right? So user can pass anything. And if you are going to build a query or SQL command with user inputs, so whatever user pass to the user interface might be a part of the SQL command you pass to the database. And if as long as users pass valid inputs, there won't be any problem. But at a time user or malicious party look at this application and pass some carefully crafted malicious input, where it take part in this SQL command and behave in an unintended behavior, that is where this exploitation happens. So let's say, so this is an example server-side script. So let's assume the DB connection is established at this point. So this is the program where it is going to filter out, select asterisk from products where price is less than given value and order price. So it's basically what it attempts to do in this application is the application wants to filter products in this product repository, which is lower than the given price here. So the user has provided the price that the user is looking at, and all the products which are lower than that price will be listed, right? So that application requirement is implemented in this way in the program logic. So this user input is passed to the logic, program logic, through this variable, and it will be a part of SQL command. So that is why we call it, this is dynamically building, right? For another user, this value will be different, right? So this value is the user passed value, which comes here in the query, will be built with the user passed price and whatever the products, right? So we are extracting product data from the product table, select asterisk from product, where the condition is price is lower than the user specified price, and we are going to order all these products based on their price, right? So that is the requirement, and this is the dynamic query that we build in the program logic. So this build query will then pass to execution, right? So execute the query against the database. So this is calling database to execute this command that we built here, and then the result will be received at this variable, and thereafter it's about displaying the results, right? So this result set will be displayed in a particular way where it will be printed in the browser for the user, right? So this is an example how dynamic SQL queries are built in order to cater user requirements, user inputs. So there are multiple forms of SQL injection attacks, right? So first order SQL injections, second order SQL injection, and lateral SQL injection. And there can be many other categorizations as well. And first order SQL injection is the insertion of SQL queries or parts of a query into a parameter that will be concatenated with the SQL command executed by the application, right? It's basically the injection, SQL injection type we have discussed so far. So we insert SQL query or part through the user interface, and it will come to the program logic, and program logic will build a dynamic SQL which concatenate with the input we pass to the application, and it will be executed. And the second type is called the second order SQL injection. So in second order injection, SQL injection, insertion of SQL queries or parts of a query as string data into storage, and will affect an application SQL command that processes the data stored previously. So it is basically we are injecting SQL query or part to the user interface, and it will be stored in the storage somewhere in the database, and will affect application SQL command that will be built maybe later, right? So it is not directly impacting, but it's a deferred or delayed impact will be happening with this second order SQL injection. And there is another type called lateral SQL injections. So it is basically manipulating built-in functions or environment variables in the database management system. So it will be affecting results or any other activity in the database. So first, let's look at SQL first order SQL injections. So this is an example, right? So user login. Right? That is the primary example that you will see most of the uh, learning materials about the SQL injections, right? So here you see a user interface with username and password, and when you press login button, it will do the validation in the program logic, and if the username and password is valid, acceptable, you will be allowed to log in, right? So how this program logic has been implemented. So the script is given here, the program logic. So the program receives a username through this text field, right? So get username will give the username of the user, and it will receive the password. Get password method will get the password field contain, right? So now we have these two variables that are holding username and password. So based on this username and password, we build a SQL query, and then we execute that query to know whether this username and password is already stored in the database table. So the SQL query that we are going to build is select count ID, which is basically we are counting the IDs that matches with this criteria. So what is the criteria? Count ID, select count ID from users table. So we are looking at users table, and the condition that we are going to match is in this users table, we need users who have the username with given username, right? We have concatenated this variable here. So username should equal to the given username, and password should equal to the given password. So if the username is equal to the user given username and the password is equal to the user given password, and we are filtering out such users from the users table, and we count, which means we look at how many users we have with this criteria matching, right? So if there is a user, if there is an actual user with this username and password, then there should be one record which matches with this username and password, right? So if there is no user with username password matching, then it will retrieve 0 records, right? So how we are going to identify we have a valid user with username and password or not is, so this query will retrieve the number of records that matches with this username and password. So if this number of records equals 0, which means there is no such user in the database with the same username and password, right? So which means we do not allow login. So we do call login failed, right? So we do not allow such users to log in. So else, which means there are records, right? The number of records that matches with this criteria is not 0, non-zero, which means at least there should be 1. So in that case, which we allow login, right? So that is how this login system works, right? So by looking at it, it doesn't have any problem at all, right? So if there are users with valid usernames and password, they will be allowed, because when they enter their username and password here, their provided details will be validated against the user table details records. So if the user provides the username and password he or she has provided earlier and stored in the database, then they will be allowed to log in. And if someone attempts to log into the system with invalid username or password, they will not be allowed to log in, because the retrieved number of records will be 0. So login will not be allowed. So this is how the system has been built. So what if someone passes Jimmy as the username, and for password, the user passes this particular text, right? So, so it is basically whatever characters you can input to username or password field. So in this case, particular user has entered Jimmy as the username, and password is given in this way, right? So what will happen when the user click on this login button? So this data will be passed back to the program logic. So the program logic will be built with this user inputs, right? So the SQL query that we build in the program logic with the user given data will be like this: select count ID from users table, where username equals provided text here is Jimmy. So that will replace the variable here, Jimmy, and password field. So this entire text come here, right? So if you remember, this is how, right? So whatever the text you provide, username will come here. Whatever the text you typed as the password will appear here, right? So now Jimmy and password will appear in these two places, right? Now this is the SQL query that we are going to execute, right? So the programmer built this query with the user inputs, and then executes the SQL command here. So now this query will be passed to the database, and it will be executed at the database, and return results will be stored in this variable, right? So if we carefully analyze this SQL command that we built here, right? So it is basically asking select the number of records from users table. The criteria we have given is where username equals Jimmy and password equals 123, or 1 equals 1, right? 1 equals 1. So 1 equals 1 condition is always true, right? So 1 equals 1 condition is always true, and this condition is combined with our main SQL command with O operator, right? So in O operator, what happens is, if you have multiple conditions which are combined with O operator, then the total condition will be satisfied. At least one such conditions are true, right? So there are multiple conditions where username equals Jimmy, password equals 1 to whatever the value, and irrespective of all these conditions, when there is a O operator, the requirement is at least one condition is true. So in this case, 1 equals 1 is always true. Then even though the password is incorrect and username is incorrect, this query will run without problem and return the number of users in this users table, right? So when this username equals Jimmy and password equals 123 condition fails, even that condition fails, this condition is always satisfied. Therefore, it will count the users that matches with the criteria. So the users matches with this criteria is basically all the users, because 1 equals 1 is basically not associated with any user in the users table. So it basically counts all the users in the database table. So it will count all the users, and the number will always be greater than 0. So in this case, it will allow whoever the user who passed this data to the system to log in. So the login will be allowed to this user because of this carefully crafted password text, right? So that is what we call SQL injection. So through this password field, an attacker has passed part of a SQL query, which will be used to build a dynamic SQL in the program logic and violates intended behavior, right? So this is a SQL injection. So even though you don't know a valid username and such user's password, you still can log into the system by providing this particular part of the SQL command. So the query after passing this text will be like this. So select count ID. ID is the column in the users table. So we are going to count the number of IDs that matches with this condition. So with this condition, there won't we are not going to uh, filter out any record in users, because this condition is always true and has no constraint imposing on the data. So it will retrieve all the user IDs. So we count it, and the number will always be greater than 0. So this is another example, example 2. Let's say there is a user interface. You can pass 4 inputs, user inputs, input A, B, C, D. So what happens with this data you pass in this interface is, in the program logic, it PB, PC, PD, which are the corresponding values here, here, and here. So that will be used to calculate some value here. So this calculation method will calculate the value with the help of these BCD inputs, and then it builds a SQL query, right? So what is this query? A select aspect from personal information table where column A equals PA. So column A in this personal information table should match with the data you provided here. and column X in the table should match with the whatever the value we computed here with the help of BCD inputs, right? So that is the uh, query that we are going to matching, and the condition that we check is column A of the table should match with the data provided here, and column X should match with the value that we calculated here. And then we execute this built SQL query and print the data. So what if we pass, right? So what if we pass an input like this, right? Input 1, 2, 3, 4, 1 equals 1, right? So this text you pass through this input field will appear here, because that is the variable. PA is the variable that is going to hold this value. So this whatever you enter here will appear in the program logic. When you are building the SQL query, it will appear here, right? So now whatever the text you entered here will appear here. So now our query that we build in the program logic is select asterisk from personal info table, where column A equals 1, 2, 3, or 1 equals 1, which means either this condition or this condition. So this is always satisfying. And two hyphens, two dashes. So in SQL, two dashes is typically commenting out the remainder of the statement. So after this point, whatever the SQL command that we build will be ineffective, because we have commented it out, the remaining part, right? So the effective SQL query that we are going to execute is only this part. Because with this two dashes, we declared that remaining part is commented, right? So only this part will be executed, and it will allow retrieving all this data, right? So the condition is always satisfying with this input. So it will select asterisk, which means everything in the personal information table will be extracted because this condition is satisfying, right? So, and it will be executed. So print this variable content is basically everything in the personal information table will be printed. Another example, user login. User enters username and some random password, colon, drop table users, and commenting text, right? So what will happen when you press or when you click on login button, this username and password will be passed to the program logic. So it will build a SQL query like here. So what is the query that we are going to build with this text? Select count ID from users, where username equals Jimmy and password equals 123, semicolon. So semicolon declares the end of the SQL query, and after that, whatever appear will be regarded as a new SQL query, right? So this part will be another SQL query, and the remaining content of this query will be commented out, right? So it is basically we are executing two different SQL queries, right? And when you execute this query, this particular part might not be really important, as there might not be a user with user Jimmy with the given password, because we don't know whether the user Jimmy exists in this system, or even if Jimmy exists, we don't know what is the password. This might not correct. But the second SQL query comes with this user input is the danger. So if it is executed, it will drop the table users. So it will drop the table, which means it will delete the table, right? If we execute this SQL command, but it does is it deletes, it drops the table from the database. So after that, you won't have the data in that table. It's gone, right? So that is a major risk, right? You might lose all the data. So those are called the first order SQL injections. So you will see that there is an immediate impact, right? So you enter some piece of uh, information through a piece of SQL command through user interface, and then it will be concatenated with the program logic built SQL query, and when it is executed, there is a high risk of violating the program in intended behavior. Second order SQL injections. Second order SQL injection is a SQL injection which does not make any immediate impact. So in first order injection, you see that it immediately violates its intended behavior. So the attacker or whoever the malicious party will gain immediate response, right? And in second order SQL injection, you will never have such immediate impact. So what happens is crafted SQL command. So the malicious party crafted SQL command will be implanted into system. So if the attacker uh, enters some SQL command crafted particularly for this application, that will be stored, it might be stored in the database. So you won't see any particular response in that case. So implanted into system and will be executed later while another function is being executed. So this stored SQL command will be used by some other process or maybe another application or another program when that particular part of the program is executed. So at that moment, it will violate the intended behavior, the expected behavior. So that is how this second order SQL injection is different from first order SQL injection. So in first order injection, so you see an immediate impact. So you violate the intended behavior immediately. But in this case, in second order injections, whatever you input as the malicious SQL command will be first stored in the database, right? So you can't gain anything from that. Perhaps later, when another program or another application or another instance, when that data is being used, so this second application, second program might go into a violation of intent and behavior of this stored data. So that is why we call it second order SQL injection. So in order to do this, attackers need more knowledge of system, because they need to know which applications, which program are going to use which data, right? So there should be internal knowledge about the program and its structures. So this is a example like user registration form. So a user enters their details, right? So it's a user registration form, a common user registration form that any application may have. And whenever a new user wants to register with the system, they enter their personal details and pick username password combination and press on this register button. So they will be directed for the registration. So in this case, this user enters some different or strange username. So strange username that the user enters is admin apostrophe dash dash, right? And password is whatever the password the user picks, right? So this is not so, I mean, this is a different text, and in the program logic, there might not be mechanisms to detect such strange usernames. So these are text, right? Ultimately, different users might pick different usernames. So if we do not have any particular way of defining username, then this will be allowed, right? So what happens when register is this data will be saved in the database, right? So perhaps it is saved in the users table, right? So this new user now is stored, or data is stored in the user table. User ID is given, first name, last name, address, and the selected username is stored in this column. It is admin apostrophe dash dash, and password is stored as a hashed password. So now everything is okay, right? Nothing happened, right? Nothing strange. A new user is registered, right? So the registered user will gain nothing with this registration, right? So parallelly to this user, there is another user in this system called administrator, right? And administrator has a username admin, right? So system administrator is also a user of this application, and the system administrator's username is admin, right? So now you see that there is something fishy here with this user, Peter, right? And then this registered user, Peter, right, with username admin apostrophe double hash is going to change his password. So this is the typical user interface that we see in an application when there is a password change is required, right? So you have to type your current password and then you have to enter your new password 2 times because you are going to confirm. So now user, right? So this new user enters his or her current password and new password is also presented here, right? So now the user's username is admin apostrophe double dash, right? So now when the user wants to change this password, so the user presses on the save button, the corresponding SQL query that will be built in the program logic will be given here, right? So how we are going to update something? So this is a password update, no? Right? So we are just going to update the password of a existing user, right? So update table. So what is the table that we are going to update? User table. Update table user. Set password field, right? So we will enter new password here. New password will be specified. And we have to update the password of this specific user, right? So how we are going to filter this specific user? We have to impose a condition where this password has to be changed only for the given user, right? This particular user. So where username equals, so this username will be taken from logged in user global variable. So that is a global variable where it holds who is the logged in user. So the logged in user is admin double dash, right? So when we build this query, it will be like this. When at the time of execution, update table user table will be update and set password column to new password where username equals admin double dash, right? So this is where it affects, right? This is where it affects. Now what happens is because of the careful crafting of username of this malicious user, now the admin's password will be actually changed, not the attacker's password, right? Now the admin's password will become this new password, right? So it is effectively changing the administrator's password, right? Because after this point, right? After this point, whatever the SQL query we are going to build is ineffective because this is commenting out the rest of the query, right? So it is only valid up to this point. Update table user, set password into new password, where username equals admin, right? So this new password is only known by this attacker, right? Even the administrator has no idea about this new password. So now what the attacker can do is attacker can now log into the system with attacker known password, right? So this is a second order SQL injection where this malicious SQL is injected to the system in one instance and it will be actually used in another instance, right? So this is called second order SQL injection. Lateral injections, lateral SQL injections. So lateral SQL injections these are exploitations of database built-in functions or procedures that does not take user given inputs. So it is actually uh, not an attack with the help of user given inputs, but exploiting database functions or database procedures. That is how these lateral SQL injections are happening, maybe by altering environment variables. So I have given more details here. It's a external resource. If you are interested, you can read it. So this is a SQL, lateral SQL injection example, right? So there is a stored procedure here, create or replace procedure. So stored procedures are like it is similar to program logic that you can write with whatever the programming language. Modern database management systems allow writing program logic within the database management itself using this very specific programming language called PLSQL, right? So PLSQL, you can write your own program logic within the database itself, right? Not in any other place. So now your program logic is also in database. So stored procedures and functions are a way of writing this program logic. So this is such an example. We have this is a procedure. Date proc is the name of it, and if you look at the body of this procedure, it takes system date. It takes system date into this variable date, and then it creates a SQL query. Select object name from all objects where created date, which is a vdate variable that we declared earlier, right? So it's basically we are looking at all the objects that were created on a given date. So this case, given date is current date. Sys date is basically in a database context. Sys date is about the current date. So it will execute this statement here, and what happens is DBMS output is enabled, right? So it will execute this statement and print the output here. So that is the rough idea of this database stored procedure, right? So it is basically looking at what are the database objects that has been created in a given date, which means if you execute today, it will look at what are the database objects that has been created today, right? So this vdate is always sys date, which means current today. So I'm going to highlight these parts, right? So we take the sys date, and we have a variable vdate, it's a date type variable, and this is the usage of it. So that will be concatenated with the SQL query that we are building within the stored procedure. So the exploitation happens here is sometimes these date formats can be changed by high privileged database users, right? So this is such an attempt, right? Alter session, set NLS date format into this, right? So what happens here is there is a particular environment variable called NLS date format, right? So its uh, format, it holds the date format in this database management system. Whatever the date type variable will represent or will present dates in a particular format. So here we are setting the way it shows, it represents data in a date format. So query will become in the previous stored procedure, right? So there is a SQL statement here which uses a date variable here. So if we change the way that we represent a date in this system, that will affect everywhere that date variables are used. So this is a date variable, and if we change the format of date variables, that will affect here as well, right? It will affect here as well. So it will be changed. So what we have done is we have changed the date format, and now what happens is this new format of the date is this, right? So let me erase the pen. So what we have altered here, this statement, it alters session NLS date format, which is the date format, and we set the new format is like given here, right? So what happens is whenever there is a place where date variables are used, this new format will be applied. So this new format is given here, right? So it does not contain any date, but rather it's an empty string with a condition which is always true, right? So now the SQL statement within the stored procedure will become select object name from all object where created date equals empty or 1 equal 1, right? So this will be always true, and it will return all the objects that have been created in this system, right? So that is, we change the date format and will affect somewhere else in the database management system. So that is what we call lateral SQL injections, right? So attacker should be able to modify session level settings. So the attacker should be able to modify such a sensitive area. So the attacker should be someone with higher privileges. So some of the configuration variables or environmental variables that you can change, such as NLS date format, NLS timestamp format. So if you change such variable formats, it will affect everywhere these variable types are being used. So attacker should be able to call the procedure. So if attacker cannot call this procedure, then there won't be any result that the attacker can see, because the attacker only changes the variable format, but attacker cannot call that procedure, so the attacker cannot take advantage of it. So exploiting SQL injection. So what usually do when it comes to exploitation, to launch effective SQL injection attack, it is important to know uh, the database server software, which means basically the attacker needs to know the details about the database and the version and all these, some information related to the server. So there are two ways identifying DB: non-blind fingerprinting and blind fingerprinting. So in non-blind fingerprinting, induce an application to produce some results for a given input SQL commands which indicate what the database is. So unless properly configured, it is easy to generate output that provide information about the uh, unless properly configured, it is easy to generate output that provide information about underlying technology. Examples are database error messages unique to a vendor. So this is an example. A malicious user can leverage information given in error message if the error message contain DB provided error text. So deliberately we present these inputs. So we know that we will not be able to gain advantage of it, but we know that if error appears, it will contain more informative detail. So this is basically something we can see when in some of the applications, when the error occurs, it shows some database management system provide messages. So here it shows database system provided error message where Microsoft ODBC SQL Server driver SQL Server column user ID is invalid in the select list because it is not contained in an aggregate function, so blah blah. So with this error message, we can gain all a lot of information, which is, it's a Microsoft environment, right? The running server is SQL Server, database management system is SQL Server, and it has a table called users, and the table users has a column called ID. So such as lot of data, also lot of information is now disclosed with this error message. And some of the things that you can try out is uh, if we pass this select version, uh, very database management system specific queries that we pass, right? So if it responses to a particular query, we know that it's uh, particular database server, right? So as an example, if you pass this particular text, right, we know that it is either Microsoft SQL Server or MySQL Server. So let's assume that there is a user interface like this just to search about products. So you can type whatever the product you want and it will search. So this is the corresponding query given in the program logic and how it is implemented. So instead of providing a valid product, you present or attacker present this text. So in blind fingerprinting, inferring information about the underlying database by observing the behavior of the web application responses to craft SQL injection payloads. So attacker does not receive direct feedback about the database structure or data. Instead, they analyze the application's responses to deduce information about the database. That is what we call blind fingerprinting. So it is employing indirect means of approaches to extract information related to the database, exploit vendor-specific SQL syntaxes, process, and specifically string concatenation can be uh, employed in such case because different database management systems employ different ways in concatenation. Now we are looking at prevention strategies. So for SQL injection prevention, the first thing that we can do is input validation. So we can filter uh, specific, special characters, very specific input types, and also we can include escaping, right? So escaping will help us whatever the character you enter through the user interfaces or as user data, with the help of escaping, it will be passed to the program logic or maybe the database as the character itself. So it will not have any SQL meaning in it. So also another very strong way of denying these SQL injections are parameterized or prepared statements, and also stored procedures, ORM frameworks, also useful in tracking down these SQL injection attacks. So input validation and escaping. So once it is escaped, these special characters, right? These special characters will be passed to the query as a particularly very special character, not just as a apostrophe, right? So escaping characters make input values are treated as a string in a query. So it will not have the same meaning as earlier. And prepared statements, which is one of the strongest way to counter. So this is how prepared statements are used in two programming languages, PHP and Java. So instead of directly creating a string query and execute it, we have a different mechanism called prepared statement, right? So in prepared statement, what we do is we first prepare the statement before we passing the actual parameters, actual values to the SQL query, we prepare it. So basically what we mean by preparing is without the exact values, we build a SQL query and pass it to the database and make the database ready for it. After that, we will be passing our input data, which now database will consider as just inputs. It will not violate the, or it will not alter the query at all, right? So you see that first we prepare the statement here with the provided query, and the values that we are passing is specified with this question mark. It shows that these are just placeholders which will be assigned later on, right? So even in Java, when you call prepare statement, so you have to specify the query that you are going to prepare. And these are placeholders that the programming language specify that these values will be assigned later on. So now first let's prepare the SQL query. So what happens is database will prepare for it. So the database will build the query and do the initial work for the query and ready to be executed. So later on, we can set values for these prepared statements. So you see here, statement dot set string. So we set all these values after the preparation. Now these values will be passed to the database query that we prepared earlier. So we can execute the query without altering the query. So it guarantees that the query will not be altered. These are just values for the placeholder we specified earlier. So that is one way of solving this prepared statement. So we call that when a typical SQL query, when it is being executed, it goes through a different set of steps or maybe phases, right? So we call first the query will be compiled and then it will be executed. So in the compilation phase, a query will be passed. Passing means it will check for syntax errors and all the language compliance, right? And then it will check the semantics with the query has true meaning. And after this, the query will be optimized. So it is optimization is basically it will evaluate the defined query for different ways of execution and identify a better way to execute it. So after doing all these things, there will be a query execution plan, right? And thereafter, exact values of this query will be bounded to the execution plan, right? So this is where prepared statements involve, right? So when the programming language declares a prepare statement, it will go through this compilation phase and build the query execution plan. So after this place or this step, the query will not be changed or altered at all. So next, what we can do is only binding values, right? So here you see prepare statement. So we pass the query and ask the database to prepare it. So it will do the parsing semantic check and build the query uh, execution plan. So now the database is ready. So its next step is we are passing the values, right? So passing the values means binding the values to the query execution plan. After that, we will evaluate execute. So even though you have some strange characters, strange inputs, malicious inputs, those inputs will not be able to alter the query, right? So those malicious inputs will be taken as just strings. So the query will not be altered. So that is how it protects against SQL injection. So parameterized queries or the prepared statements are pre-compiled, right? So when we ask programming language asks to prepare it, database will compile the query. So the input values are inserted as parameters to this compiled query. Query alterations cannot be done. Stored procedures and functions are similar to this. So stored procedures are also similar because stored procedures and functions are database objects which are pre-compiled. So whatever the built into the stored procedure and function, those are pre-compiled. So whatever the values you pass at the time of calling this stored procedure will be considered as just values. So it cannot alter the query within the database stored procedure function. And ORM frameworks also solves this problem to a certain extent because it will have some measurements built into framework. So it uses parameterized SQL queries whenever it is interacting with the database, and it may have filtering inputs, so it will minimize the threat. And another option is using web application firewalls, specifically when the application is a web application. So we can have a web application firewall. So it will filter out some of the unnecessary or invalid input patterns. So it is mainly a rule-based system. So these rules can resist SQL injection attacks by filtering common SQL injection patterns. Right, so that's all about the SQL injections. And if you have any question, let me know, we can discuss, or else we can end the session. Okay, it seems there are no questions. I will end the session now, and next week the lecture will be, or the session will be conducted by a different lecturer from our staff. So it is a different topic which focuses on noise QA related security implications. So there will be a couple of sessions from that lecturer, and also in future there will be some cloud database system specific security measurements will be discussed by a visiting lecturer. So that is how the remaining lecture plan is about. Right. So I will be ending this session now, and thank you very much, and good night for all of you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.